So this lesson we're going to discuss how to find the area of parallelograms and rhombuses. But first let's look at a parallelogram. So you can use the formula for the area of triangle to help us get the formula for a parallelogram. Okay, so notice how a parallelogram can be split up when we create our diagonal into two triangles. So if we know the base of this parallelogram, call it B, and we can find the height of this triangle, call that H, then we could find the area of one of those triangles. Okay, so the area of this first triangle, the whole thing, is base times height over 2. But since we have two of these triangles, when we find out the area of both of these triangles that are congruent triangles, then the area for a parallelogram is just base times height. So recall that these are going to be congruent triangles because opposite sides in a parallelogram are congruent. And so through side, 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 we know that they're congruent triangles. And so we know that their areas must also be the same. So we can use our knowledge of triangles to help us with parallelograms. So the area of a parallelogram is base times height. So our base and our height. Notice again how our base and height are perpendicular. This is very important. They are perpendicular. So we don't want to we want to make sure that it's the height that's going straight up and down through the image. If we were given a parallelogram that had sides of 10 and 2, we would not be able to find the area of this. We need to find the height first. And it's the height, it's going to be the same height throughout that whole image. Okay, so the base and the height must be perpendicular. So let's look at this example. So as seen before, we're given 8, which is that slanted length, and then we have 10. And then we have our height going straight up and down. But notice how this triangle on the side is a 45, 45, 90 triangle. So in order to find the side of this triangle, we can divide the hypotenuse by root 2 to then get the length of one of the legs. So we have 8 root 2 over 2, which is 4 root 2. So if this is 4 root 2 here, then the height is also 4 root 2. So you're going to have to do a bit of digging in order to find the height sometimes, and that's okay. But after we do that, we're plugging in what we know. We know our base is 10, and our height is 4 root 2. So 10 times 4 root 2, we do 10 times 4, which is 40, and then we keep our root 2 units squared. So again, this is when our special right triangles are coming up, and when our special right triangles will be important in us finding the area of the figures. Okay, so now we're going to talk about a rhombus. It's a little bit trickier, but what's one way we can find the area of this rhombus? Well, we know that the rhombus is a type of parallelogram, so couldn't we just do a base times height and find the area of this parallelogram? Sure. But what if we weren't given the height? It would be very challenging for us to find the height. So we're going to derive a new formula, a formula that's a little bit simple, but it's a little bit complicated to get it from. So we're going to go through it bit by bit. But before we move on to derive this new formula for a rhombus, let's remember the properties of a rhombus. Remember that the diagonals will bisect each other. Okay, the diagonals are also perpendicular, and the diagonals bisect the corner angles. Okay, so we're going to use this knowledge to help us get the formula for the area of a rhombus. Okay, so let's look at this figure. We have two diagonals, it's a rhombus. So we know all four sides are congruent, okay? And we also know that they are perpendicular. And we know that the diagonals bisect each other. So if we look at these four triangles, are these four triangles congruent? Well, let's think about it. We have our base, which is 2 ticks, times our height, which is 3 ticks, divided by 2. So you get our first one, base 2 ticks, height 3 ticks, divided by 2. We can get the same area there. And then base and height, base and height. So we have 4 right triangles here. So what we could do, we could find the area of each of these 4 right triangles. Okay, so we're going to, instead of calling the variables x and y, I'm going to use variables d for diagonal. Okay, so are the diagonals in a rhombus congruent? Your answer is no. It's not all the time. If the diagonals in the rhombus were congruent, that would be a square, and then we know how to find the area of the square. So when we're looking at this particular diagram, we have two diagonals. We have two diagonals of different lengths. We have this diagonal, which is the shorter diagonal. So I'm going to call this diagonal 1, diagonal sub 1 divided by 2. Okay. So this bigger diagonal was cut in half because the diagonals bisect each other. This longer diagonal here, we're going to call diagonal 2. So it was diagonal 2 divided by 2. Okay. So that means if I added up D1, added up this piece and this piece, we'd end up getting diagonal 1. And if we added up this piece and this piece, we end up getting the whole length of diagonal 2. Okay. So let's look at one of these triangles. Let me draw this here. I'm going to bring it over here. So this was D diagonal sub 2, so the second diagonal cut in half. This was diagonal 1 cut in half, and we have our right angle. So notice how we have our base and our height. So to find the area, we have base times height over 2. So instead of saying over 2, I'm just going to multiply by 1/2. Okay? So here at the end of the day, we have D1 times D2 over 2 times 2 times 2, which is 8. Okay? So that's one of these, the area of one of these triangles. Because remember, area is 1/2 base times height. So I'm actually multiplying by the 1/2. So if that is one of these triangles, how do we find the area of all 4 of these triangles? So what we end up doing is multiplying D1, D2 over 8 by 4. And then when we reduce, we end up with diagonal 1 times diagonal 2 over 2. And this is our new formula for finding the area of a rhombus. It is tricky to think about diagonal 1, diagonal 2 over 2. So it's the whole diagonal. All of diagonal 1, all of diagonal 2, you multiply those, and then you divide by 2. So we used our knowledge of parallelograms, we used our knowledge of rhombuses to help us get this formula. So let's look at these two examples. Let's look at the first one. So it's a rhombus. What is the entire length of that first rhombus? So diagonal 1 I have is 4. Diagonal 2 I have is 10. So the area for a rhombus is diagonal 1 times diagonal 2 over 2. So 4 times 10 over 2 gives us 20. So the area of this rhombus is 20 square units. And now if we look at this last one, we have one diagonal here, right? 4 plus 4, that gives us 8. So one of the diagonals is 8. But the other diagonal, we don't have any information for. So we have this length, the 4, and the 5. So this is a 3, 4, 5 right triangle. This is a Pythagorean triple. So if this length is 3, we know that length is 3, making this whole diagonal, diagonal 2, 6. So D1 times D2, the whole diagonal, diagonal 8 times 6 divided by 2 gives us 24 square units. So this may be a little tricky to think about, this new formula for a rhombus area, but it will actually help you simplify finding the area of a rhombus and knowing about the diagonals of a rhombus. Let's do one more problem. So if we know that the area of a rhombus is 100, again, the formula for the area of a rhombus, D1 times D2 over 2. So one of the diagonals times the other diagonal over 2. And if the length of the find the length of two diagonals if one is twice as long as the other. So if I had this length and that was x, diagonal 1 was x, then diagonal 2 would be 2x. So let's see what we get. So if our area is 100, that means A, we're plugging in 100. And if diagonal 1 is x, diagonal 2 is 2x, and we have to divide that by 2, our 2's cancel out, and we're left with 100 equals x times x, which is x squared. And then when we take the square root, we get x is 10. So when we want to find the lengths of both diagonals, one of the diagonals is 10, and the other diagonal is 20.